रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम सुब्हानल्लाहि व बिहम्दिही सुब्हानल्लाहिल अज़ीम व बिहम्दिही अस्तग़फिरुल्लाह. My today's video is about the mechanics of the apple and the knife. Okay, so the apple is stuck inside the knife is struck inside the apple, and with the help of a mallet we hit the knife and we observe that the apple goes up, it rises up the knife. Okay, so the mallet applies a force of F units on the handle of the knife, and the knife accelerates in this direction, downward direction, because previously it is held by the hand, this hand, left hand, at rest before the mallet hits. But as soon as the mallet hits the top of the knife, it accelerates in this direction. When it accelerates in this direction, it causes a vantage point in space called Tahir center of rotation. So it's kind of like it's being attracted towards this center. So it's kind of mechanical force or gravitational force, not gravitational, but just like mechanical force. So it creates a Tahir center of rotation here. Okay, so when it creates a Tahir center of rotation here, then this mechanical force F, when it produces acceleration in the knife downward, the apple goes up with an acceleration. Only the knife goes down because apple has got some degree of freedom, and so it can move, it can react to the applied mechanical force. So the knife, there is a centrifugal force, Tahir inertial centrifugal force acts in this direction on the knife. How? In my previous video 18, I got this Tahir inertial centripetal and centrifugal force couple, two forces in opposite direction. Okay, so what we will do, we will superimpose this couple, Tahirian inertial centripetal couple, over here. When we superimpose this couple here, then this F mechanical force exerted by the mallet held in the second hand, other hand, right hand, is replaced by this centripetal is replaced by this mechanical force, because this mechanical force is active, this is not active. So this replaces this part of the couple. So this, then the tug of war is between this force F and the Tahir centrifugal force. So this is the Tahir centrifugal X here. So I have separated the motion of the whole system into two parts. One is the motion of the knife going down with an acceleration A, and the same mechanical force acting on it, I mean the centrifugal force acting on it, and being counteracted by the mechanical force, or the mechanical force acting on the knife and the knife going down with an acceleration, and the centrifugal force counteracting the mechanical force. So summation of R, this is R from Tahir center of rotation, the distance along the line of action of the most of the forces, the direction is R. So summation of R is equal to 0 minus F, the mechanical force, plus FCK, the centrifugal force in the knife. This, the centrifugal force in the knife given by this, V square over R for B is equal to 0 and dr over dt is equal to 0. And plus minus dv over dt for beta is equal to minus plus pi by 2, and dr over dt is equal to minus plus v. When this is positive, these two are negative. When this is negative, these two are positive. So that's how we break it up into two parts. Okay, so we deal with this portion because the motion is happening in line, but I still retain the name Tahir center of rotation even though there is no rotation. Okay, so we get mk, the centrifugal force acting on the knife, we get mk dvk over dt. As soon as the motion starts, the relative motion between the apple and the knife starts, the knife goes down with an acceleration and the mechanical force, and the apple goes up. Now something strange is happening. This mechanical force is this mechanical force is converted into this, is counteracted by this centrifugal force. When this centrifugal force acts on the apple, which has got some degree of freedom to move, this same acts as a mechanical force on the apple, thus causing another centrifugal force in the other direction given by F centrifugal in apple, which is given by this, the same as this, ma times 0 dr over dt is equal to minus v a slash k. The only difference is that the velocity of the apple is the velocity relative to the knife, to a vantage point or frame of reference on the knife, because apple slips in relative motion to the knife. Okay, so this is the velocity of the apple va with respect to the knife. So we get a centrifugal force on the apple when the same centrifugal force which is developed in the knife is then converted as a mechanical force into the apple, because the apple actually moves. So when it moves with the mechanical force, so it creates a vantage point in space called Tayet center rotation, like when the knife is acted upon by a force and it creates a vantage point in space called Tayet center rotation. Like, just consider it analogic to, like, here we got the sun and here we got the earth, and the earth is being attracted towards the sun and the centrifugal force is acting in the opposite direction. It's just an analogy, actually it's not true. Okay, so when this centrifugal force gets converted into a mechanical force in this direction, but remains the same as, the value remains the same as F or mk dvk over dt, it creates a Tayet center rotation here, and the centrifugal force on the apple, which is given by this, acts away from the Tayet center rotation. Okay, so we got now another force mag, the mass of the apple. This angle is theta. This angle with the vertical is theta. Okay, so now we have two more forces, ff, the friction force between the apple, and the mag, the weight. Okay, the weight component in the line of action of the forces is mag cos theta, and the friction force is given by here mu time. Mu is the coefficient of friction between the material of the apple and the inside material of the apple and the knife, and mg sine theta is the other component, normal component of the apple acting on the knife, plus 2 times the integral of the contact pressure between the apple and the knife times the dA differential area. If it's a linear function, then P contact pressure can be taken out, but if it's a function of the width of the apple along the portion of the knife struck in the apple, then we need to integrate it, and the area is just on the one side of the knife, so we need to multiply it with 2 so that we get the contact pressure on both sides. Okay, so the friction force is given by this. You can insert it here. So summation of Fr is equal to 0, like summation of Fr is equal to 0 minus F plus Fck, force on the centrifugal force on the knife, is equal to 0. Here we will not. Okay, so where Ff is equal, okay, so summation of Fr is equal to 0. So this minus mg cos theta minus ff, this is the negative direction, this is the positive direction, minus the centrifugal force on the apple, that is counteracting the centrifugal force that the apple got in the form of a mechanical force acting upward, or a reactive force acting upward. Okay, like a mechanical force can produce a counteractive centrifugal force, similarly a centrifugal force can produce a counteractive mechanical force. Okay, so minus mag cos theta minus ff minus this plus this fck mk dvk, which is equal to f. So m dva is equal to this minus minus f, and this is f. This is f. So f minus ff minus mag cos theta. So this is the value of the acceleration of the apple with respect to the knife. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Thanks for watching.